are the executables that will be used to test your homework responses, right? These are known good solutions, so definitely take a look at these. Yep.
If we already turned it in, can we like do the executables and then we use it in?
Sorry, can you?
If we already turned them in, can we do the executables like just do them and then return it in?
Yeah, so you can actually continue to overwrite your turned in homework till the deadline. So if you call the bundle command again, it'll overwrite your submission until the deadline. Once we hit the deadline, you can no longer run the bundle command. Great. And then somewhat related to the class, Data New is running a tutorial on Vim this afternoon. Definitely not a requirement. You guys can use Emacs. But if you start to use Vim and you want to learn a little more, they happen to be doing this. Great. So let's dive in. Last time we were talking about math with my computer. We were talking about math, and we finished off with a discussion of mathematical expressions. I just wanted to review the tail end of that lecture before moving on to additional arithmetic operators. So we talked about the assignment, right? And how assignment was a little different than the other types of expressions we went over. So again, these are examples of expressions, mathematical expressions. And you can assign an expression simply by having a variable on the left side of an equal sign. And these were all examples of assignment. So again, when you have an assignment, it evaluates the expression on the right and stores the result in the variable on the left. And much like standard expressions, the assignment expressions actually have a value, right? So you can actually say, this equal sign, this circumference equals this expression. This entire expression has a value, right? And this allows us to chain assignments together. You saw this last time, where we can set x equal to the value of this assignment, and the value of that assignment is simply 3, right? And so in this case, if you were to chain them together, x would get set to 3. It would get set to the value of that assignment in parentheses. And it's important to keep in mind that assignment expressions are evaluated right to left. That's the reverse of the other types of expressions that you saw. So here's just an example of the chain, right? So if we didn't have the parentheses here, let's see how we'd interpret this. So if we didn't have the parentheses in this assignment expression, the ordering or the defined precedence would be to evaluate this c equals 0 first, and then go down the chain from right to left. Is that pretty clear? And then we talked a little bit about value mismatch, right? So this was the case where we're assigning an expression that has a type on the right, and that expression has a different type than the variable on the left. So what happens in that case? Well, we get type conversion, right? The expression on the right gets converted into the type of the variable that you're assigning to, that variable on the left. And so what happens if we're converting a larger type or a more complex data type into a smaller one? Anybody remember what happens? Well, not necessarily 0. What happens is information can get lost, right? So in the case of a double to an int, this was a form of round off, right? And we always round towards 0. So in this example, we have integers x and y, and they're going to get a sum. So if we were to multiply this integer y with a double, 3.6 in this case, the assignment would actually be an integer, right? Because we have to down convert to assign to that variable. And so information is lost. Conversion to an int always results in truncation.
So do you have to typecast?
So we're going to get into typecasting in a couple of slides,
Alright.
and that's why I wanted to go back over this, right? And so another example here where x is an integer, again, y is an integer, and we're dividing by a double. So this expression would have a double value because it gets upgraded due to this double. But when we do the assignment, it gets downgraded into an int, and we lose information. And the final example here, z is a double. We're dividing y, which is an int, by another int. And when we do that, the value is 0, and the assigned double is 0, right? We can't recover the lost information. So that motivates the next topic as we get into more arithmetic operators. And that next topic is typecasting, right? We often need to explicitly convert a data type, and we can tell the compiler to do that. And so a few examples of where we want to do this is when we explicitly want to round off numbers, or we want to deal with these types of integer operations, right? In this division, you'd want the result to actually be, you might want the result to actually be a double, right? So this guy doesn't just go down to 0. So to do that, we use something called a casting operator. And the syntax is pretty simple. You indicate the type inside parentheses in front of the expression. And what this does is it converts the expression to that type. So let's see some examples. So here we have the expression 2, and we want to cast it into a double, right? So this 2, remember, the compiler sees this 2 as an integer because there's no decimal point. So when we cast it, now the compiler will see this entire expression, this entire value as 2.0 as a double. Similarly, if we want to take a double here, 2.8, and convert it into an int, now the compiler would see this as the integer, and so forth. Pretty straightforward? Okay. So this is something called a unary operator. So most of the operators you've seen so far, like plus, minus, they are binary operators because they work on 2 quantities. This is a unary operator. It just works on one expression, right? You can't put expressions around it. It doesn't interpret it. And it turns out that the casting operator has the highest precedence in the sequence of operations. So that means the casting will happen first before the other operations. So here's just a little example where we have 2 integers I and j, and 2 doubles x and y. So in this first expression, right, we're assigning I divided by j to x. In this case, what do you guys think will happen? Yeah, we get 0. So let's take a look at all of these example values of x. We get 0 because this expression is has the type of an integer. It doesn't turn into a double until we do the assignment. So let's say we actually wanted this to be a real number operation or a double operation. We can do that by casting, right? So we can cast I into a double. And so now this division operation gets upgraded to a double operation, right? As we saw last time. And so the resulting value will be 0.5. Similarly, we could have casted j. And in that case, we would have upgraded, again, that division operation to a double. What do you guys think happens in this example down here? Yeah, it goes to 0, exactly. And the reason for that is because of the parentheses, we're saying calculate this expression before applying the casting. So we don't upgrade until after this integer division happens. So what do you guys think the value of x is here, where we have passed the
1,003.
yeah, and so it'd actually be 3.0, right? Because now what happens is we're saying, okay, turn y into an integer, so it gets turned into 3, and then when we do the assignment, it gets upgraded back into a number.
So the casting and the whatever comes after the casting becomes like casting. So if it's I divided by j there, everything becomes a double because of the casting.
Yeah, because of the parentheses. Okay. So in this case, because there's no parentheses and casting has the highest precedence, the casting would be applied to the I before the division.
Alright.
So order of operations is really important.
So if you have like the double I divided by j, so it doesn't matter if the j is an integer.
So in this case, you mean?
Yeah.
Yeah. So what happens? What we talked about last time was that when we have mixed types in an expression, the result of the expression takes the highest type, right? We have that rank ordering, and a double is higher than an integer in that rank ordering.
On the bottom example, put the int in front of the x instead of the y, would it work just like same way?
That wouldn't actually be a valid assignment expression, because so what the compiler always expects on the left-hand side is a variable, not an expression, right? So if you had put the int on this side, you would have gotten a compiler error. So